So in this video, we're going to walk through the scoring guidelines for 2018, the FRQ for question 1. Question 1 is a long FRQ, and I'm not going to show you the entire problem to start off with because you wouldn't be able to read the type. So we're going to look at A, B, and C first, and then D, E, and F. It is a good idea to read through the entire problem before you get started, so that you know where you're headed and know what prior information you may need to use for later parts of the problem. Here we have an oxidation reduction reaction, and they're asking for the enthalpy change. The question A asks for the oxidation number of chlorine and sodium hypochlorite. Then we're going to be asked to calculate the number of grams needed to prepare 100 milliliters of a 0.5 molar solution. And then they give us some data information about what solutions the students is using, and we're asked to determine which reactant is the limiting reactant. So let's get started on question number 1A. In part A of the problem, they are giving us a compound and they're asking us to determine the oxidation number of the chlorine atom in that compound. So I'm going to go ahead and write the compound down here. All right, and the way I tackle this is I usually write the oxidation numbers up top and I do my math down here. Okay, and you start with what you know. There are some rules that never change based upon a compound. I know that my group 1s, which sodium is a group 1, are always going to be plus 1. Oxygen is always going to be a -2 unless it's in peroxide, in which case it will be a -1. Chlorine, if it's forming just a binary ionic compound, it's just going to be the charge of that particular ion, but that's not the case here. So I can't make an assumption that that is -1. So I'm going to assign that my variable x. Now I'm going to do the math. You're going to multiply the oxidation number by whatever subscript shows up. These are all 1. So 1 times 1 is going to give me 1. -2 times 1 is going to give me -2. X times 1 is going to give me plus x. Since there is no charge, this is a neutral atom, all of those oxidation numbers will add up to 0. So when I do the math for this, it turns out that x is equal to +1. And this was a common mistake that students made on this exam. They assumed that chlorine would be -1, and they didn't go through and do the math for this problem. In part B of question 1, we are being asked to calculate the number of grams of the substance to make 100 milliliters of a 0.5 molar solution. So we are going to be using this formula. We know that molarity is equal to moles over liters of solution. This is not liters, so I would have to convert that to liters, and I would rearrange this formula to say moles is equal to molarity times the volume of the solution. So the molarity is 0.500 times 0.100, and that should give me 0.0500 moles. And that's the first part. So you would earn 1 point for figuring out moles. The second part of this problem is you're going to use the moles that you figured out. So 0.0500 moles of my substance, and get into the habit of writing all 3 of those things down when you're solving it, just to keep yourself honest. And I'm going to multiply that by the molar mass. So I know that 1 mole of this compound is equal to 158.10 grams. And I'm not figuring that out on this slide, but you should know how to do that. And when I do the multiplication, it should be equal to 7.9 grams. Okay. So I would put that mass in a volumetric flask and add 100 or add distilled water until it reached the 100 milliliter standpoint. Be careful, one of the things they may ask you is how much water would you use, and you would say I would add distilled water until it reached the 100 milliliter mark. In part C of this problem, this is a good example of that claim, evidence, and reasoning that we talked about last week. The claim they're asking you to make is which one is the limiting reactant. You need to use the data that they provide as evidence to justify your answer. And if you're justifying your answer, you do need to address the evidence that they provide you. So let's take a look at the evidence. Two parts of the evidence are the data table and the balanced equation. And from my balanced equation, I know that I need, if I look at the molar relationship, I need 1 mole for every 4 moles for every 2 moles. Okay? And if I look at how much I have in terms of the molarity and the volume, if you multiply 0.5 times 0.005, you should get 0.0025 for all of these reactants. Since I need the most of this, based upon the data that is provided, sodium hypochlorite would be my limiting reactant. Okay? And you would need to justify your answer based upon how much you have and how much you need. You could do all the math, but since they're all the same, you have the same number of moles for all of them, you can just figure it out for one and say, based upon the molar relationship, I would need 4 moles to every 1 mole and 2 mole, and I do not have that molar relationship. In part D of question 1, they're showing you a graph of how the temperature changes when everything is mixed together. And you'll see that the temperature is going up. We're starting at this temperature, so that's going to be my initial temperature. And I end up right about here, that's going to be my final temperature. You do have to pay attention to these markings. That's 32, that's 34, so this line right here would be 33. And they only go to the 10th place, so when we are solving this, please make sure you pay attention to your significant figures. So to solve for the change in temperature, we're going to take our final temperature, subtract from it our initial temperature, and that should give you, so we're starting with our final temperature is 32.5, subtract from that 20, and you should get 12.5 degrees Celsius. So that's going to be our delta T, and that's going to be important when we look at future parts of this question. There are 2 parts to E in this question, and I've gone ahead and included the balanced equation in here. We're putting all of the reactants in an insulated calorimeter, and the temperature of the reaction is going to be monitored. So their part I of E, they're asking us to calculate the magnitude of the heat energy. So that's Q. They've given us the mass. On the last part, we figured out our delta T, which was 12.5 degrees Celsius. They're telling us that the heat is released. So I know it is an exothermic reaction. And if it's exothermic, my delta H, the magnitude of my sign, is going to be negative. They're giving us a specific heat or telling us to assume the specific heat is 3.94 joules per gram degree Celsius, and that really no heat is absorbed by the calorimeter. So this first part of the problem is a Q problem, and that is the formula that I'm going to use. They've given us the mass. I would make sure that you are writing down all your units of measurement and making sure that they cancel out as well. My specific heat is 3.94 joules per gram degree Celsius. They are asking for joules, so I'm good there. Grams is going to cancel out. And my degrees Celsius will also cancel out. So when I solve for Q, it is 749 joules. And I'm not going to put the sign in here because they're asking for the magnitude of the heat released. So we don't need the sign in this first part. The second part, they're saying using the balanced equation and your answer to part C. So I'm going to go ahead and write my answer to part C. In part C, I figured out that my limiting reactant was sodium hypochlorite, and I had 0.0025 moles of that substance. So that's what I found out in part C. They want us to calculate the value of the enthalpy change of the reaction in kilojoules per mole of reaction. So I know, and it is delta H, so my answer is going to have to be negative here because they are asking for the correct sign with your answer. So I already know that this is joules. I'm going to need to convert that. Oops. To kilojoules. And since it is exothermic, I'm going to go ahead and put the sign in there. So I have the top part of this problem. The bottom part is what might be a little bit tricky for you all. So, but they did give you some clues. They want you to start with what you know from part C. So I'm going to start there. I know that I have that many moles of sodium hypochlorite. Okay? And I also know from the balanced equation, because they're telling me to use the balanced equation, that if I have 4 moles of that reactant, that will result in 1 mole of the reaction. 1 mole of the balanced reaction. Okay? You're always going to use that to figure out the moles of reaction. So when I do that, and I do that math, for every 1 mole of reaction, I'm going to consume 0.000625 moles of my limiting reactant. Okay? Now we're just going to divide those two values out. So it's 0.749, sorry, negative 0.749 divided by 0.000625 gives me negative 1.20, 3 significant figures, times 10 to the third kilojoules per mole. Last two parts of question 1. In F, they say the magnitude of the enthalpy calculated from the results of the second experiment, in which the student doubles the volume, is going to be the same as the result calculated in the last problem. So if I look at these units of measurement, kilojoules per mole, let's see how the moles change. So if I figure out the moles for this second experiment, I've got 0.005 moles, whereas in the last experiment I had 0.0025 moles. So the moles of my reaction is going to double. Heat is an extensive property, so if you change or increase the amount of the substance, you are going to do the same to the amount of heat either absorbed or released. And since this is a ratio, the delta H of the reaction, or the enthalpy change, is going to remain the same. So that answers part F. Part G, they ask you to write the balanced net ionic equation, which means you're going to exclude your ions that are soluble, always. Those are your group 1 and your nitrates. Okay, so if I come up here, that's a group 1, so I'm going to get rid of that, I'm going to get rid of that, going to get rid of that, going to get rid of that, and that. To figure out the charge, you can go backwards, cross and drop. I need 2 sodium for every one of those, so the charge of my anion would be a -2. Make sure you're putting those charges in. And I only need 1 mole of that. I would need 4 moles of that ion and 2 moles of my hydroxide ion. And that would give me 2 moles of my sulfate ion, which is a 2-, 4 moles of my chlorine ion, that's in solution. This is not in solution, so we're going to include that exactly the way it is. And that would be your net ionic equation.